Welcome. Today, we're diving into the basics of number systems in mathematics. Number systems are the foundation for counting, measuring, and performing calculations. They provide a consistent way to represent numbers, making it possible to communicate and solve problems in math and beyond. Whether you're just starting out or brushing up on your knowledge, understanding number systems is essential for mastering mathematics. In this video, we'll explore the different types of numbers, the numeral systems used to write them, and why these concepts matter in everyday life and advanced math. Let's get started by looking at the types of numbers you'll encounter. First up are natural numbers. These are the basic counting numbers we use every day, 1, 2, 3, and so on. They're denoted by the symbol, and natural numbers are the building blocks of mathematics, used for counting objects, ordering, and basic arithmetic. Whenever you count apples, steps, or books, you're using natural numbers. They start from 1 and go on infinitely. Understanding natural numbers sets the stage for learning about more complex types of numbers. Next, let's see how whole numbers expand on this idea. All numbers include all natural numbers, but with one important addition: 0. So whole numbers are 0, 1, 2, 3, and so on, and are represented by the symbol W. 0 plays a crucial role in mathematics, acting as a placeholder and representing the concept of nothing. Whole numbers are used in situations where counting can start from 0, such as the number of items left after something is taken away. This simple expansion makes whole numbers more versatile in mathematical operations. Now, let's move on to integers. Integers take things a step further by including all whole numbers and their negatives. This means integers cover -3, -2, -1, 0, 1, 2, 3, and are denoted by the symbol I. Integers are essential for representing values below 0, such as temperatures, depths, or elevations below sea level. They allow us to perform operations like subtraction and understand concepts like loss or decrease. With integers, mathematics becomes more flexible and applicable to real-world scenarios. Next, let's talk about rational numbers. Rational numbers are numbers that can be expressed as a fraction, written as p over q, where both p and q are integers and q is not 0. The symbol for rational numbers is q. Examples include 3, 4, -2, 5, and even whole numbers like 2, since 2 can be written as 2, 1. Rational numbers are everywhere in mathematics, from dividing a pizza into slices to calculating averages. They help us understand parts of a whole and perform precise calculations, but not all numbers can be written as fractions. Let's see what comes next. Rational numbers are numbers that cannot be written as a simple fraction. Their decimal expansions are non-terminating and non-repeating. Famous examples include the square root of 2 and pi. These numbers are essential in mathematics because they fill in the gaps between rational numbers, making the number line complete. Irrational numbers are used in geometry, trigonometry, and many scientific calculations. Understanding them helps you appreciate the richness and complexity of mathematics. Now, let's see how all these numbers come together as real numbers. Real numbers include all rational and irrational numbers. In other words, any number you can find on the number line is a real number. This set is incredibly important because it covers almost every number used in daily life and science, from simple counts to complex measurements. Real numbers allow us to perform all basic mathematical operations and solve a wide range of problems. With real numbers, we have a complete system for representing quantities. Now let's shift our focus to the numeral systems used to write these numbers. Numeral system is a way of expressing numbers using specific digits and rules. The most common is the decimal system, which uses base 10 and digits 0 through 9. In computing, the binary system, base 2, uses only 0 and 1. There's also the octal system, base 8, and the hexadecimal system, base 16, which uses digits 0, 9, and letters AF. Each system has its own rules for how digits are arranged and what value each position holds. Understanding these systems is crucial for math, science, and technology. Let's look at how digit positions and bases work. Each digit's value in a numeral system depends on its position and the base of the system. For example, in the decimal system, the rightmost digit is the one's place, the next is tens, and so on. The Hindu-Arabic numeral system is the most widely used globally. Operations like addition, subtraction, multiplication, and division are defined within each number system, making calculations possible. Mastering these basics is essential for progressing in mathematics and applying math in real-world situations. Let's wrap up with a quick summary. Sum up: understanding the basics of number systems is crucial for learning mathematics and its applications. We've covered natural numbers, whole numbers, integers, rational and irrational numbers, real numbers, and the main numeral systems. These concepts form the backbone of all mathematical reasoning and problem solving. Whether you're studying math, science, or technology, a solid grasp of number systems will help you succeed. Thanks for watching, and keep exploring the fascinating world of mathematics.